Okay, sorry about that. I don't know what the heck happened with my calculator, but it's back and it's working. So for my capacitive impedance here, I get minus J 31.8. Okay, so that's my impedances. And now I can go ahead and try to solve this problem. So I've got Vx of t here, which I know. I've got Vy of t, which is what I'm trying to solve for. And so let's go ahead and write our KCL expression here. Let me actually just go on to the next slide. I left myself some room, so let's copy this right on over to the other slide. Copy. I'm going to go here. So I left myself a slide to do this example. So let's go ahead and do our KCL. So I1 is basically going to be Vx, or 3.3 angle 0, minus Vy of t over negative J 31.8, right? Equals, and then I2 is just going to be Vy of t. You know what? Instead of writing these in terms of t, right, we're in the phasor domain, so let's write them as phasors. This will be Vx, and this will be Vy. So let's just write them that way. This will be Vy, this will be Vy, 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 minus 0 over 50, so just Vy over 50. That's I2. And then for I3, I've got Vy, and hopefully you notice, but I have these two impedances in series, so I can actually just divide by the combination, the series combination of the two, which is going to be 50 plus J 50.3. Okay, so now I have everything I need, really. All I have to do is go ahead and do the math here and solve for Vy. Okay, so let's go ahead and try to do some of this math. It's a little bit annoying to do all this math. I do understand that. It's part of the curriculum here, so you're going to have to get through it with minimal complaining. So we've got 3.3 angle 0 divided by minus J 31.8 minus Vy divided by minus J 31.8. I guess I could just go right ahead and add that term over to the other side. So let's just say equals. And then I've basically added this term over to the other side. Right? Yeah, that's correct. Plus Vy over 50 plus Vy over 50 plus J 50.3. I'm writing so sloppy here. 50 plus J 50.3. So clearly I can factor a Vy out of all of these terms here. And I should get something like 3.3 angle 0 divided by minus J 31.8 equals Vy, which is what I'm trying to find, multiplied by 1 over J 31.8, that's going to be minus, plus 1 over 50, plus 1 over 50, plus J 50.3. All right, and so now I should be able to multiply both sides by J 31.8 or by minus J 31.8, and I should be able to take care of some of these fractions here. So I can say 3.3 angle 0 degrees Vy. That J 31.8 and the J 31.8 here are going to go to a value of 1, which is nice. Then I get a minus J 31.8 over 50, and then I get a minus J 31.8 divided by 50 plus J 50.3, which is probably the ugliest term here. And what I'm going to have to do is I'm going to have to get this entire piece here into a form where it's just a rectangular with a real part and an imaginary part. And once I do that, then I can convert it into a phasor, divide 3.3 angle 0 by that phasor, and I can obtain Vy, okay? But for now, I think that this part of the video is getting a little bit long, so I might have to go into a third part. I'm going to go ahead and end this here, and I'll wrap up the math in the next video. I'll go ahead and end this.